The current automated fiber-placed machines can only produce large open surface parts which cannot meet the growing interest in small complex structures from industry. By employing a rotational stage, a parallel robots, and serial robots, the dexterity of a fiber placement machine can be significantly improved for manufacturing complex composite parts. Demonstrating the procedure will be Pengcheng Li, a PhD student from my lab.
Begin by loading the frame definition file through the software of the optical CMM. Click Positioning and Detect Targets, and select the targets that are attached on the motors of the parallel robot. Click Accept to use those targets as the positioning reference of the whole system, and in the Entities list, click Base Frame and select Make this reference frame the origin. To define the tracking model of the end effector platform frame, select Tracking Models, click Detect Model, and select the targets fixed on the end effector platform of the parallel robot. Click Accept and click Tracking Models. Select Up Platform in the dropdown and click Up Frame. Then click Apply and File, Export, and Tracking Model and enter a file name to save the tracking model. To define the tracking model of the tool frame, select Tracking Models and Detect Model and select the targets fixed on the tool frame of the serial robot. Click Accept.